Okay, time for our math lesson. We're starting lesson 91, and our problem solving, I'm not going to go through all the steps with you. You guys should be very familiar with all of those. I'm just going to review the diagram with you. So hopefully you guys used in your diagram the land of gallon G. And then you drew your two queens. This stands for the courts. And each queen had a prince and a princess, which stands for the pints. And each prince and princess had two crowns. They had an everyday crown and they had their very dressy crown. And then, of course, each crown had 8 opals on the crown. Okay? Now, and hopefully you remember the story of the land of Gallon. I think those 4 queens were particularly beautiful. Anyway, coming back to math, if you can draw this, you have no problem with the problem. Because the problem wanted to know if you have, let me see, let's get back over here to the problem solving. 2 gallons of punch for a class party, and the punch was served in 8-ounce cups. Then 2 gallons of punch was enough to fill how many cups? So, if it's 2 gallons, you're going to know, let's see, there's 2 cups in a pint. You've got 2 pints in a quart. So that's 4 cups per quart. So if you have 4 cups per quart and you have 4 quarts, 4 times 4 equals 16. That's 1 gallon. But if you have 2 gallons, you should have gotten 32 cups. Now the key to this too is you had to remember how many ounces are in a cup. 8 ounces. That's the tricky part. So if you remember the 8 opals in the crown, eight opals in the crown, 8 ounces in a cup. Okay? All right, so that's as much time as we're going to spend on that today because I wanted to get, oops, my classroom is falling down. I wanted to get to the lesson today. Also don't want to scuff my wall up. There we go. I wanted to get to the lesson today. I'm going to move the camera here a little bit. Hopefully that'll get a little bit better view of what we're writing. It's a good review today on the decimal place value. We talked about place value a lot in that, there we go, I think that's a little better. We have discussed about what kind of a number system we have, and you're familiar, we have what is our number, what's the name of our number system? It's like the Arabic, but what is it based on? Base 10. So we have a base 10 number system, and with that base 10 number system, it tells us that we can count anything that we want to count with 9 digits. So our 9 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We can count anything. You give it to me, we can count it. We can put those in any combination. And these numbers are also what we call whole numbers. So everything that we count, there would be one whole thing that we count, a whole number. Now, we do have these digits to count things with. And the way our number system is designed is there's a pattern to it that goes along with our base 10. And it tells us if we just put all those numbers up any which way, we'd never know how many we had because there wouldn't be any conformity and uniformity of how our number system is designed. So the way we do that is we have come up with place values in our number system. And we know any number that I put up there I know that the ones place is always the farthest number to the right. That is the law of mathematics. That is the ones place. Okay, so I can put that name of that place value there. Then it tells me I can use any of these numbers in this place value. However, if I want to go to where I have more than I can put in that one place value, there's just one spot in that place value. I can go anywhere from 0 all the way to 9, and I can put that number there, no problem. But once I hit 10 and I get 10 ones, there's my magic number, base 10. When I get to 10 in my ones, I have to go over a place value. So when I get 10, I have to say, oops, that becomes this place value because I need to have 2 numbers to represent the 10. So I have 1 10, no ones. Now, I can use this place value, and this is the tens, and I can use this place value all the way from 10 all the way down to 99. 99. And when I hit 99, I have to go to the next place value right here, which is hundreds. And I do that so on and so on and so on. Now, the thing that these place values, how they relate to each other, we use that in social studies too. How do the words relate to what we're talking about? We also have to decide, how do these numbers relate? How do these place values relate? If we look at the ones place value and then we look at the tens place value, the tens is 10 times bigger than the ones. And the hundreds are 10 times bigger than the tens. And so on. Every time we go to a new place value, it gets bigger by 10. It gets bigger by 10. 10 times bigger. Tens are 10 times bigger than the ones. The hundreds are 10 times bigger than the tens. Okay? The thousands are 10 times bigger than the hundreds. So if that is true, that just does it. It's a great system for counting, and it works for us every time. So if I were to have a number, and we use it in life. So if I have an apple, I have 1 apple. And if I add an apple, I have 2 apples. Yeah, you guys, you got that? Yeah. Okay, so if I have an apple, and what if, life is certainly not always certain, right? Look at us, right? Virtual learning, who would have ever thought? But what happens if I have an apple and It's pretty good. Now I don't have 2 whole apples. Now what do? What does the base 10 system do for us now? I don't have 2 wholes. So sometimes in life, we have numbers in between. How do we count for a half-eaten apple? How do you count for the numbers that are in between the whole numbers? We have a solution. Okay, so if we have that's my apple. If we have one apple and it's whole, and we have another apple and it's whole, I can get 2. One apple and one apple is 2. Okay? That's easy. But then we have to have a system for this where we have an apple and perhaps it's been cut into 1, 2, 3 pieces. So our base 10 system accounts for that. So now we can have all these numbers. We can have wholes and parts of wholes. So how do we know which one of these numbers represents the wholes and which numbers represent the parts? We got the wholes and we got the parts. How do we represent that in mathematics? There's something that we have to have, a point of reference. And our point of reference in mathematics is the decimal point. The decimal point tells me this number right to the right, saddled up right next to that decimal number is always going to be ones. So now I know where I'm going. I know that our numbers are always grouped together in groups of 3s, ones, tens, hundreds, ones, tens, hundreds. So now I know exactly what that number is. And I know all of these numbers, I know what their place values are. You should know what these place values are too. Hopefully this is a review for you. So our place value is our point of reference. Here's our ones. Here's our hundreds. Oops. Let me just teach that correctly. This is our tens and this is our hundreds. Okay? All right, so we have our place value. If the numbers get bigger going this way to the left, and they increase by 10 every time, then it would be reasonable or make sense that the numbers going this way on this side, here's our frame of reference, our decimal point. In the US, it's called, we use a dot and it's a decimal point. Other countries, it is not always a dot, but the period is what we use for a decimal point. From the decimal point left, they're going to get bigger, and that's all familiar. So it would think from the decimal point to the right, it would be reasonable to conclude that they would get smaller. And so this is how we account for numbers that are parts of numbers. You've got your whole numbers to the left, and you've got your part of numbers to the right of the decimal. And the decimal is how we account for having whole things and having parts of whole things. Okay? So, now, what that would look like is, if I had, well, you know, I'm going to get this eraser fixed one of these nights, one of these days. Who knows? I kind of like to do my math lessons at night. All right, so if we have an apple, the whole apple would be here in the ones. if I divide that apple up, and I just take maybe this part, much of it, 2, 3, 4, 5, 6, 7. Let's say I have 7/10 of that apple. This place value, because this is times 10, then it would, if this gets bigger, then it would make sense that this side is going to get smaller, and so I would have to divide by 10. So that's why this is tenths, because it's 1/10 of 1. And keeping on that pattern, if I took this 10th and I divided it into 10, each of those pieces into 10, if I took 2 of these, that would be 20 hundredths. And this is 1/10 of 1/10, because it's getting smaller by 10. Okay, so you've got tenths. Do you remember the second place value? To the right of the decimal is the hundredths. And the third place value is the thousandths. And remember, you got to put that on it. This has this on it. This has just okay? All right. Now, I think that's really all that we need to talk about today with your math lesson. The thing that really makes decimals make sense, it always made it make sense to me, was when I used money. So if decimals and place value kind of throw you off, always think of money. So like if you have $52, and remember we say and with the decimal, we reserve the word and for decimals in mathematics. If you have $52.37, here's your whole, ones and tens, and then you have your tenths and your hundredths. And if you think about what goes here, this is usually your dimes. How many out of 100? 3 tens out of 100. And this is your pennies, which there's 100 pennies make $1, right? 100 cents, C-E-N-T in Latin, 100. So I think money helps a lot with place value. Now remember, the other place value over here is your thousandths. And if you remember, I believe that we have talked about this before. There was a coin that was coined in the United States. I think it was like in 1870 something, 1874, I want to say, somewhere around in there. And it's called the mill. And the mill was 1/1000th of a cent. Or, yeah, it's 1/10 of a cent. So it's 1/1000th. Okay, now they stopped making them about 1960. They stopped making them, and they're totally not used anymore. If you have one or can get one, they're probably very valuable. But we do use the 1/1000th as a form of payment every time you go to the gasoline station. So look, next time you go to the gasoline station, they use the 1,000th place value to charge you for your gas. So it's the only place I know of that they still use that thousandth place value. So that's it for math. We will do lesson 91. Let's do the odd problems. And if you have any questions, please let me know. I live to help you. So happy mathing. I'm going to finish my apple.